right, today we're going to look at configuring cube high availability, and we're going to be doing that on the new Catalyst 8000V virtual edge router. And previously, I did a video on the installation of the 8000V on ESXi, which you can see in the background. That's what I have. And today we're going to use that to configure cube high availability. Okay, so obviously using the 8000V as a cube router, Cisco Unified Border Element, with SIP trunks going to call manager and the carrier. So that's what we're going to be looking at. So to do that, we need to start with a few configurations. This is a basic install, just like in the video that I did, with just your basic installation. I can log into it, and it's got an IP address, a DHCP IP address on Gigabit 2, but that's pretty much it. That's all it has. And so we're going to start configuring this and look at what kind of things need to be done to be able to get the high availability working. Then we're going to test it to make sure that that the two routers see each other, and we're going to take a look at the cube configuration as well. So with no further ado, let's get started. So first of all, we need the track config, and this is so that it will track the line protocol of the interfaces to make sure that they are up. So interface, we're going to do Gigabit 1 line protocol. Okay, and we also need to do that for Gig 2. Okay, track 2 interface Gig 2 line protocol. All right, so with that done, we can start looking at the redundancy configuration. So we do redundancy, application, redundancy. Okay, we need a group, so group 1. We need to give it a name. We need to give it a priority. The default priority is 100. We're going to have 101. The primary router is going to be higher than the secondary router. So I usually will do priority just one step above, priority 101. The secondary will be 100. So we'll look at that in a second. We're going to do our timers. Okay, so now what that's telling you is that after a delay of 30 seconds of the line protocol being down, it will then reload the router, or it'll delay it for 30 seconds after a switchover, and then after 60 seconds, it will reload the router. And now we need to give it the control. What interface is going to be doing the control? And that is interface Gigabit 3. And I'll show you that in just a second. And then the data. And then we put our track statements in here. Okay. And that's the configuration for the redundancy portion of it. We need to take a look at some of the interface commands. Now, my interfaces don't have the IP addressing on them quite yet, so we're going to go ahead and do that. So do 1. Redundancy RII 1. And now we do the redundancy group that the RII is telling it that this interface is going to participate in the redundancy, and then we give it the redundancy group. And then we give it a VIP address, a virtual address. Okay. Now this virtual address is also going to be used on the secondary. So when the call manager is configured for the SIP trunk, the IP address that it's going to be using is going to be the inside interface, is the inside virtual interface that we configure. And on the same hand, on the carrier side, the carrier is going to be pointing to the virtual interface that we configure, which is, in this case, 172.16.10.10. Okay, we got an extra R in group back here. And that's what that virtual interface is going to be used for. Therefore, if we have a failover during the middle of a call, the IP is going to be staying the same. The IP address that is being used is still going to be the same, and therefore the call will remain up that way. And we do a no shout. Okay, and let's take a look at interface 2 now. Now this is my interface that I've used. I've only given a DHCP address, not a static address, so I'm just going to leave it that way. But we need to do the very similar thing to what we just did with interface gigabit 1, and that is we need to tell it that it's going to be in the redundancy, using the redundancy. Okay, it's the second interface in this case, but we still use the group 1 for this configuration, so redundancy group 1, but we give it an IP on the internal IP address range. You didn't put that exclusive at the end there. Okay. And we don't need to do a no shut there. And then finally, we need to look at the third interface, which is gigabit 3. We need to give it an IP address. Now this is used for the checkpointing, just to communicate between the boxes, and it just really needs to be connected on the back end. For example, in ESXi, just needs to have a connection back there. So this does not need to be a routable subnet to other devices. It's just communicating between these two boxes. And we'll do a no shut, no other configuration needed there. Okay. Now the final piece that we need to configure is in the voice service VoIP configuration. And that is the redundancy dash group 1. Okay, now it does say that you have to reload the router for the configuration to take effect. So a good rule of thumb at this point is just go ahead and we're going to save our configuration. We're going to do a reload on the first router. And we're going to go ahead and take care of the configuration on the second router. Okay, so we're going to do all that again. So first the track commands. My protocol. Okay, our redundancy. Application redundancy. Group. Give it a name. Okay. Now remember I said the priority needs to be priority 100. Now if I try to do this, it's going to tell me that it's already configured, no change in the configuration. So that is the default. We're going to put our timers. And the control, gigabit 3. Data is gigabit 3. And we indicate our track again. Okay, now we need to go to our interfaces again. And this time, oops. Okay, 16.10.2. Okay, we're going to tell it that it's part of the redundancy with the RII. We're going to give it the redundancy group. 10.10, which is the same IP that it was on the first one. And no shut. We go to interface 2. Do redundancy, II 2, group 1 for the redundancy here. E105, which is what it was on the first one. And our interface gigabit 3. And no shut. And again, we go to the voice service VoIP and redundancy group 1. Okay, and we need to go ahead and write the configuration. And we're going to reload and confirm. Okay, so as soon as that comes back up, we're going to log into both of them again. And we're going to run a couple of commands, the show redundancy application group 1 to to tell us what is the current state of the redundancy or the high availability. And then I'm going to show you what you need to do to fail it over. And we'll take a look at that as soon as that router comes back up. Okay, the second router has rebooted and is back up, and I'm logged in. So now we're going to take a look at what the status is of our redundancy group. So to do that, we're going to do a show redundancy application group 1. And it helps if you spell it right. Put an E in there. All right. So let's take a look at what we got here. Okay. So it says what its current role is. This is router 1. And so its current role says that it's active. The peer, which is router 2, is on standby. Okay. Peer presence, it is there. Yes. The communication is there. Yes. And progression started. Yes. Okay. And then if we take a look here, it says our RF state is active and our peer RF state is standby hot. It's ready to go. Okay, so let's run that same command here on the second router. Show redundancy application group 1. All right, now if we take a look, my role on the second one is standby. The peer role is active. That's the one that's currently active now. Okay. Peer presence, yes, the communication is there. It's all the same except the roles are reversed. RF state standby hot and peer state is active. So our configuration is correct. Everything that we did was right and it is currently in a good state. Now, let's say we want to manually fail this over so that the secondary route is the one that needs to be active. So to do that, we're going to do redundancy application reload group 1 self. Okay. Now, if we wanted to do this from the secondary, we could do that as well. All we would need to do is, instead of self, use the peer command, which we would do on the secondary. Now I'll do that when I put this back. So I'm going to do that. Okay. And we see the redundancy group, group 1 reload self. Okay. So now if we take a look at that same command to take a look at the status, okay, now we see that the secondary role is active. Peer role is now in standby. Okay, RF state active. Peer role is standby. And if we take a look at that here on the primary router, we see that the roles have now been reversed. Standby, peer role is active. Now let's take a look again at that command that we just did. And let's put in peer. Okay. Oh, that's interesting. It's not active. Okay, so we're going to have to do it on here. So redundancy, application, reload, group 1 self. All right. Give that just a couple of seconds. I'll take a look at it again. And now our role is now active again with the peer role and standby. We do the same thing on the secondary, and we see that its role is standby now, but the peer role is active. Okay, so that's the configuration for high availability using the Catalyst 8000V virtual edge router. And now we're going to take a look at the cube configuration. So what we need to take a look at for the cube configuration is first we're going to take a look at some of the configuration for the voice service VoIP. Okay. And all of these configurations are going to have to be matched on the secondary router. They have to match, they should match exactly, so that in the case of a failover, that the same configuration is going to be there. So there's no difference in that configuration. Okay, so we already put the redundancy group in for when we were looking at the high availability. So now we're going to put in, do a mode order element. That needs a dash. All right, that tells us that we need to reload the router. We will do that later. And we're going to do allow connections, SIP to SIP. Okay, we're going to go into our SIP configuration and we're going to put in early offer forced. Okay, and we'll exit out of that. Okay, so let's go ahead and do that on the secondary router as well. Okay, service VoIP. Okay, mode order element tells us we need to reload, and then we need to do allow connections, SIP to SIP. We don't need to do H323 to SIP or H323. We're not doing that on this router. We're doing SIP only. So we don't want to introduce anything that's H323 on this. And we'll go into the SIP and early offer forced. Okay, now we need to take a look at some of our voice class commands. Now these are very good commands. I really like them. Really help with the configuration. So first we're going to do a voice class URI CUCM SIP. Now what this is being used for is to match calls that are coming from the call manager IP addresses. Now whether that is one call manager or several call managers, you can put that in here. Okay, now if you had a couple of such subscribers that calls are going to be coming from, that's where you would put that. You would continue to do that. Okay, and that means that it will match from any of the IP addresses of the call manager service. Okay, and now we need to do that same thing for the carrier. Okay, now this is the SIP proxy address that the carrier gives you, that the calls coming inbound from the carrier are going to be addressed with. Okay, and now I don't have a carrier set up right now, so I am just going to do a bogus IP address just to show you exactly what it needs to be done. All right, so that voice class is done. Next is going to be the voice class E164 Pattern Map. Now I really like the E164 Pattern Map because prior to this, if you had different pattern ranges that you needed to do, you would have to have another set of dial peers to be able to do that. with the E164 pattern map, you can have one dial pair, but specify all the different patterns that are going to be in that are going to be matched in there. And so I really like that. So in this case, we're just going to put in so you can see exactly what that is. So in this case, it's a full E164 number. So as you can see, I have two different ranges. Maybe this can be two different ranges that, in this case, I probably could have put in, brackets with 4, 5, yeah. But in some cases where those ranges are not contiguous, that's where this really helps, okay? Or maybe you don't have full E164, maybe you just have your 4-digit extensions. You can put the 4-digit extensions. It doesn't have to be a full E164 number. It just uses that name of the E164. But this is just to tell it what patterns are going to be in this pattern map. Okay. Now, for this particular situation, we're going to take for the carrier side. And we're going to say anything coming from call manager is going to be sent to the carrier. Okay. That helps us in that we know that we're going to be using the URI to do this. So we know that our call managers are good. They're good IP addresses. So anything coming from the call managers are most likely going to be good numbers and not going to be fraud. And so we're going to say, okay, anything coming from call manager is okay, and we're going to send it out to the carrier. Okay, so that's what that one does, the .t. Okay, next we're going to do a voice class DPG. Okay, at the DownPeer group. Now, I can't put in the DownPeer here yet because I haven't put in the DownPeer. Okay, if I try to say use DownPeer, so DownPeer 100, it's going to give me an error. There's no DownPeer. Okay, so this is kind of a chicken and the egg kind of thing. Is we can't put in the DownPeer yet because the DownPeers aren't there into the DownPeer group. So we need to go configure the DownPeer. But then on the DownPeer, we can't configure a DownPeer group in the DownPeer unless the DownPeer group is configured in the voice class. So it's kind of a strange situation in that configuration. So it's good to go ahead and take care of this so that we can have that ready, and then we'll come back to this and put the DownPeers in. Okay. Now what we need is our server groups. So voice class server group 1. Okay. We're going to put a description in here telling us that this is going to call manager. Okay. And so we'll put our call manager address in here. Now, if you had multiple addresses, let's say you had 2 subscribers that were doing your calling, but you wanted to use one first and the other second as an overflow if something happened to the first one. Then you can put in a preference in there. So let's say we did IPv4. Let's say we had a subscriber at 26. And then we could do if you do a question mark there, we've got a preference statement that we can put in there. And we can say, how about we spell that right? And we're going to say that's going to be a preference of 1. whereas the first one is default a preference of 0. Okay, so that's how that would work. Again, previous to having server groups, we had to create a different dial peer for each session target that we wanted. In this case, with server groups, we can put multiple servers in there pointing at the different call managers that we wanted to point it at, and if something goes down, then the dial peer will know that it can go to the secondary one. Okay. And now we need the server group for the carrier. And so this is for if you've got two different areas, two different IP addresses that you can send to, that maybe for the carrier that are geographically separated, but they're the same carrier. And you can do the same thing that we did with call manager. You can put in secondary IP address with a preference in there if we wanted to do that, or you can just put it in without the preference and it'll do it in a round robin fashion. All right. Now, let's go ahead and take a look at our dial pairs. Now, the way I have this set up is we're only doing two dial pairs. Okay, for each call, as you know, there has to be an inbound dial pair and an outbound dial pair. Okay, in this case, if the calls are going from call manager out to the carrier, we're going to have one dial pair that's the inbound dial pair, and then a second dial pair that's the outbound dial pair going to the carrier. And vice versa, if the call is coming from the carrier to call manager, we're going to have that same outbound dial pair is going to be our inbound dial pair. And then our inbound dial pair is going to be our outbound dial pair. So I'll show you how that works. So we're going to do our VoIP dial pair. We're going to put a description in here saying that this dial pair is going to call manager. That's our outbound dial pair to call manager. Okay. Now this is a SIP dial pair, so we got to put our session protocol SIP v2. Okay. We tell it where it's going, which is our server group. Okay, we're going to give it our DownPeer Group information, and I'll go over this after we have both of them set up of what the DownPeer Group is going to do. And then we have our destination E164 Pattern Map for the numbers in Call Manager. And then for our incoming calls, we're going to do incoming URI via CCM is how it's defined. Okay. Now the codec, I'm just going to do codec transparent. And what that means is that the cube is going to be completely transparent as far as codec. It's not going to change any codecs. So if call manager is sending out at G711, it's going to send to the carrier at G711 and be completely transparent on that. Same thing goes for the carrier. If the carrier sends in the call at G711, it's going to send it to call manager at G711. Or if it sends it in at G729, it's going to send it to call manager at G729. And so there is no transcoding, there is no change in codec. Okay? And then we need to tell it this is the internal interface that we're going to bind our control and media to. So source interface and that's our internal interface. So we're going to do the same thing for the media. All right, and then we need our DTMF. RTP NTE, which is the RFC 2833, and no VAT. All right, so that is our DownPeer 1. Okay, now let's take a look at our 100. Let's take a look at our DownPeer 200. Okay, this is the one that's going to be inbound from the carrier and outbound to the carrier. Okay, so we're going to say description to SIP carrier. Okay, it's a SIP DownPeer. We're going to say our server group 2. We're going to say our destination DPG 1 for our DownPeer group, and destination E164 Pattern Map 2. Okay, now we're going to do our incoming URI via SIP carrier, which is how it was defined in the voice class. Again, we're going to do a codec transparent and our voice class commands. Binding the control and media. Source interface, this time it is gigabit 1, which is our outside interface. And media. And then we have our DTMF, RTP, NTE, and no VAT. Now, as I told you before, that we would have to revisit this, so we do our voice class DPG1. Now we have these defined, so DownPeer 100, and now we go to voice class DPG2, DownPeer 200. Okay, now let me tell you what that's doing. Go down to our DownPeers here. Okay, so again, like I said, we have 2 DownPeers. That's all we're going to have. We're not going to have several DownPeers for the different patterns. We're not going to have several DownPeers for the different call managers. We're not going to have anything like that. We have inbound and outbound DownPeers for both ways. And so the way this works, let's talk about outbound calls from call manager. So the call is going to come in and we have our incoming URI via call manager. Okay. In the Cisco documentation, the incoming URI takes precedence over any incoming call number or destination pattern or anything like that. And so it's going to come first. So our incoming URI, it's going to accept any call from the call manager IP addresses. And then what we have here is that's what our DownPeer group DPG2 is doing. It's going to say that in anything coming from call manager, we're going to be accepted into this DownPeer, and we're going to send it directly to DownPeer 200. Okay, so it's going to go here. It's going to check our destination E164 Pattern Map 2, which is a .t. That's going to go through. And then it's going to take a look at our servers, our destination, our IP addresses, which is in server group 2, which is our carrier IPs, and it's going to send it along. Okay, same thing goes on the other side. So we have incoming URI via SIP carrier. So anything coming from the SIP carrier IP addresses is going to be accepted into this DownPeer and then automatically sent to DownPeer 1 or 100 from our DownPeer group configuration here, which that is set for, it's going to check our E164 pattern map 1 and make sure that the numbers are what we have specified there, and then send it off to our co-managers' IP addresses. And that's how that works. So that's the configuration of the cube. Default configuration. Now again, if we have HA, we would need to do that same configuration on the secondary router so that it can have the exact same configuration. And call manager pointing to the virtual IP in our HA, carrier again pointing to our virtual IP in the HA. So that's it. I hope you like this video. If you do, please like, please comment below. Let me know what your experience has been with this. And if you have any problems with it, comment below. Maybe I can help you out. So please like, please subscribe. Help me to do more of these videos. And we'll talk to you guys later.